So our goal today is going to be to finish the fossils, or at least the PowerPoint on the fossil record and general features of biology. So we're going to try to get through, I'm going to review a little bit and try to talk about some of that stuff. So we talked about the fact the fossil record doesn't really exist, okay? Not in the sense that your compatriots at the government schools are taught, okay? First of all, there's not a complete fossil record anywhere. The geological column doesn't exist anywhere on the planet. We've put it together from bits and pieces that we find all over the place, right? And second of all, the fossils don't really look like that, right? You think, okay, well, if we're in the upper Mesozoic, then we might find a Triceratops fossil. Probably not. Most of the fossils in the upper Mesozoic are fossils of clams. So most of the fossils in the Cretaceous period are clams. Yeah, clams, and more clams. The occasional snail shell and things like that thrown in for good measure. Okay, so we do find human fossils, usually in the upper layers of rock. Not always, though. One example of that would be malachite man, which again was found in Cretaceous rock. Okay. Now there are other human fossils that you can look at as well. All right. So this is so good job. You actually asked a question that I was planning on getting to today. So if you Google malachite man, you'll find a lot of these pictures which were actually taken by the State Department. This is not some kind of creationist, hoax or something like that. These are, a disinterested third party that took a lot of these photos. There are a total of 10 skeletons that were found. Many of them are not articulated. I think only 2 of them are articulated. So you see in this picture here, the femur going to the the knee joint and all that. That's only about the only one that is articulated. Okay, most of them are a jumbled mess, like you see in the picture over there. All right, so this is evidence that the 4 folks that were fossilized here were killed before they were fossilized. All right, which would make sense if you're talking about the later stages of the flood, right? So you got all these theoretically humans running around, trying not to die. A lot of them maybe were on hilltops in fortifications or whatever, and they end up drowning or something like that, rather than being like initially buried. Okay, and then they get buried sometime after they have died. This is rather common with vertebrate fossils, particularly with higher vertebrates. You very rarely see them articulated. Okay, a lot of them have been damaged, or so for example, there's only one case that I know of dinosaurs that were fossilized in the middle of a fight. I want to say it's a Stegosaurus and some kind of Allosaurus T-Rex type dinosaurs that are fighting each other, and they actually get fossilized as they're fighting. So that being buried at 400 miles an hour, like we saw with the clams, apparently doesn't happen later on in the flood, which again you would kind of expect. Okay, so I would argue that these are a good example of a human fossil. This is the same layer of rock that Dinosaur National Park is a part of. Okay, so it is Cretaceous rock. It's supposed to be 120 million years old. Sorry. And it is at least 60 feet below the surface that these skeletons were found in. They were found in a copper mine Okay, so we weren't like digging around for fossils. We just were mining copper over here and we found them. All right. They were initially dismissed as some kind of burial ground for Native Americans. The skeletons don't really, I mean, it's really hard to tell somebody's ethnicity by their skeleton. I don't really think so. Most people that are buried, you find an articulated skeleton. Right? Only 2 of them articulated, so that rules it out for me. You don't bury people 60 foot deep in the ground, and you wouldn't bury them in a copper mine either. That's just, no, you're mining copper there. Why would you bury somebody in a place that you're likely to dig up later on? That's not what humans do. Then it was dismissed as some kind of a cave-in and a mining accident. I disagree with that one as well. 4 of the skeletons are female. Can't tell the difference between a male and a female skeleton. There are anatomical differences, one of them being the hips. Female hip socket, the acetabulum is actually further forward than the male one. There's some other anatomical differences in the skeleton that you can look at to determine the gender of the poor person that got buried there. Anyway, so I don't think it was a mining accident. Ladies don't do a lot of mining. No offense, but it's not really something that is appealing to. I mean, you want to spend 12 hours a day with no sunlight, you know, surrounded by, you're doing heavy labor. We're going to take these big rocks, we're going to make them into small rocks. We're going to take those small rocks, we're going to make them into smaller rocks, and we're going to take those. No, that's not, women have better things to do. Okay, so 99% of all miners in America are men. Oh, they're just prejudiced against it. Women don't want to be miners. Why don't you want to? It's a great job, great benefits. You don't see a lot of feminists protesting outside of coal mines, demanding equal treatment, and, all this stuff. No, they only want the air-conditioned, CEO jobs where you can, not get dirt under your nails. Anyway, or maybe they just haven't noticed that coal mining is dominated by it. And trash collection too. 99% of all trash collectors are men. So good paying job. It pays really well. I had a teacher one time make fun of them. That's why you stay at school, pointing out the trash collectors. And I looked at her and I said, that guy makes more money than you. So there's that. Anyway, that blessed her. So I think this is a good example of a human fossil. There's others you can look at. Glen Rose fossil formation is maybe a good example. It is true that a lot of historical finds we don't have them anymore. Apparently, the Smithsonian's been sitting on a lot of those. I haven't been able to confirm that. I don't know if anybody will be able to, because what? They might be. The whole what movie is it where they go, they pan to the end scene is that huge warehouse with all those crates underneath the Smithsonian. So one of those. There's a lot of them though, right? And the Smithsonian definitely has a lot of artifacts that they just store in a warehouse. Maybe they lost them anyway. So there's been a lot of human skeletons that kind of get sat on that way. So these ones are actually in the possession of Dr. Don Patton, who did some of the original excavations here. But human fossils are stupid level rare. And most of them, it must be said, come from a layer of rock high enough that a lot of creationists agree it was probably laid down after the flood. So,
like a mummy, be considered fossilized?
That's a good question. Not in the sense that it's part of the fossil record. A mummy, it's kind of in between, and I mean, they were artificially preserved, right?
But they're not like a rock and sediment. They're bones.
Right. They weren't laid down in rock, but they are a record of the Earth's past,
yeah.
And so I guess there's some overlap there. That's archaeology, I suppose. the more archaeology we do, the more overlap we find between it and paleontology, right? Like that site they found out in the middle of Mesopotamia is supposedly the oldest temple in the world. Something like 5% of it is even excavated and have huge columns they've excavated, and I'm kind of sitting over here thinking this could be bad. This could be the Tower of Babel. I don't know that, but they had found this huge tower in the middle. I'm like, but it wasn't finished, was it? They were like, no. How did you know that? Just a wild guess. Anyway, so the geologic column doesn't exist in the world, although the different layers do, and they generally occur in a specific order. So I'll give them that. So we don't find the missing links. I've argued that the missing links that we have found are, well, just kind of a pathetic excuse for evidence. All right. We did talk about the Cambrian explosion, right? We find at least 35 to 40 different animal phyla right there in the very bottom layer, including vertebrates down there. So the picture on the left, again, is the evolutionary tree of life, which is probably not an accurate term. I'd call it the tree of death. And then over there on the right is what we actually find in the fossil record. A couple of things I'd like to point out about the actual data from the fossil record. First of all, bacteria don't evolve at all. You find them throughout the fossil record. That column over there on the far left, that's bacteria. And they're the same yesterday, today, forever. Although the ones in the fossil record are about 10% bigger than the ones today. So there's that. We find a lot of stuff in the Cambrian and the Ordovician and the Silurian and all that we don't find today. So I would argue a lot of the original shallow sea environment was destroyed. Okay, we don't have the huge amount of shallow ocean that we used to have, right? By the way, that's where 90% of ocean creatures live. I probably said it before, but somewhere in the neighborhood of 90 to 95% of all ocean creatures live, and just 8% of the ocean, which is smack next to the land. Anyway, so a lot of that habitat has apparently been destroyed, although again, I wasn't there. I will also point out that a lot of these columns over here that we see that don't appear higher in the fossil record, we find them alive today. Horseshoe crabs, nautilus, coelacanth, lots of ocean creatures that don't get fossilized in the higher layers are still living creatures. Okay? So my argument could be summarized as this, that the fossil record is not an indication of when an organism lived and died, but where an organism lived and died. In other words, I'm arguing that you're looking at basic ecosystems, ocean floor, shoreline, the land part of the shoreline, and then far inland, which is why we usually only find 4 layers. Because that's basically the only habitats that exist in most areas of the world: ocean bottom, shallow ocean, shoreline, and inland. Okay, and where do you find the biggest, strongest, smartest animals? Right there at the top, along with the whales and very large fishes, so on and so forth. Again, we don't find the intermediate forms. Most of them are right there in the Cambrian layer, fully designed, fully formed, fully functional, some of the most complicated organisms in the world, okay? Like the trilobite. Now that might seem like an oversized ocean bug, but he had eyesight 14 times as complicated as a human's eyesight. They actually used crystals to refract light to create a perfect underwater vision. And by the way, most trilobites had eyes, right? Very, very few of them had no eyes. So my hypothesis, again, is that most of the ocean floor actually got light to the bottom of it. Okay? Which means, if we look at our current ocean as an example, it was probably less than 400 or 500 feet deep, compared to the modern day ocean, which is 12,000 feet, right? So we have a totally different planet compared to the one these guys were designed to frolic about in. How fast were these fossils formed fast. As what Ken Ham, I think, says, floods form fossils fast. Well, not all the floods. Most floods don't really do anything for you. But one example that we have looked at is the eruption of Mount St. Helens. Mount St. Helens erupted in 1980, many years before I was born. Okay. And when it erupted, we got a front row seat at catastrophism. Okay. About 600 feet of rock got laid down, most of it in a couple of hours. It covered a couple of square miles, destroyed a lot of trees. A lot of trees, we looked at some polystratic trees, a lot of trees have been blown into Spirit Lake. And the crazy thing is that as they become waterlogged, they sort of start pointing up and down because their root ball ends up being heavier than most of their branches that have been stripped off, incidentally. And so they kind of sink down, and the theory is that if you had a second wave of catastrophe that hit Spirit Lake at just the right time, you'd end up fossilizing a bunch of those trees standing upright with their root ball and maybe a couple of the larger branches in the upright position there. And a lot of them, of course, if the horizontal ones are all on a mat, you end up making that into a coal seam, right? It gets squished all together rather than being surrounded by rock and end up getting petrified. So we have very good evidence that rock layers can form quickly, okay, geologically speaking, the blink of an eye, all right? And we see this in the fossil record. We see lots of fossils that had to have been formed quickly, okay? We're looking at a very destructive event. I got a picture in here of a polystratic fossil. Again, very similar to what we found at Spirit Lake right after the eruption. We have this something like a third of the lake was covered with a floating mat of trees, most of the branches and roots stripped off, but with the bark still on them. That's kind of weird, right? They got hit by a pyroclastic flow at like 400 miles an hour. They kept their bark. Anyway, a lot of them sank down into the bottom of the lake there, and presumably are in the process of being petrified. And again, if you had another catastrophe that hit, you'd have a whole bunch of trees at the top that might have gotten squished together, and that is how you get coal, of course. Polystratic fossils are common. Coal seams have so many of them that they are the dominant fossil present. Wasn't that a coincidence? Okay. How long does it take that fossil layer to be laid down? It happens very quickly. And fast enough for a fish to be fossilized in the middle of lunch, fast enough for jellyfish and other soft-bodied organisms to be preserved, fast enough to preserve a clam in the closed position, or even in some cases while it was still open. Okay. So we know the fossil layers formed quickly. Okay. Whereas all these millions of years are supposed to have happened for evolution to have taken place? Well, supposedly they happened between the layers. Yeah, I got some problems with that idea. And we talked about this before, right? So we would expect to find an unconformity. If we were evolutionists, we were running around looking at Grand Canyon, we see the Cambrian layer there, see the Mississippian red wall on top of it, we would expect there to be an unconformity between those layers. This is an erosional boundary, and it looks like this jagged line between the two, right? Because you have erosion, you have trees and plant life and a soil layer, and we call it bioturbation when the roots get down into the soil, and they can even crack through rocks and stuff, right? So we expect to find small little rocks between two layers that are supposed to be, have some gap of time between them, okay? So we expect to find an unconformity there, indicating that sediment deposition was not continuous. However, we don't always find unconformities. In fact, there's only one in the Grand Canyon. We call it the Great Unconformity, which is hilarious. I think we should call it the only unconformity, all right? And again, finding unconformities every once in a while is no surprise to the creationists, because floods are kind of chaotic, and you might have deposition for a while, and then maybe some second phase of the flood happens, and you get erosion for a little bit, and then maybe a third phase happens, and you get more deposition in an area. We do find that in catastrophic events. Mount St. Helens, once again, being a good example of that. We find this big unconformity right between when, remember, the last rock was laid down of the eruption, and then there's a new layer of rock laid down on top of that. Okay, so there's a type of unconformity called a paraconformity that has a smooth, straight, even line between the two layers of rock. Okay, and of course it gets worse. It turns out that they're actually interbedding between many of these layers of rock. The most famous example, of course, being the Cambrian Ruoff and the Mississippi Red Wall in the Grand Canyon that are interbedded 7 times. Okay. Supposedly, there's a 200 million year gap between Cambrian and Mississippian. Okay, well, if you want to believe that, go right ahead, but I'm going to argue that the evidence is not really on your side here. Now, if that's not enough for you, it turns out that the Cambrian, the geologic column is only a general order of fossils that we find. They don't always occur in that order. Which again is no surprise to the creationists in the room. Because we think, okay, well, in a flood, sure, you're going to have most of your ocean bottom creatures fossilized at the bottom. And sure, you're going to have most of your shallow ocean creatures fossilized next, and most of your shoreline creatures after that. And every once in a while, something gets washed down into the bottom there, so you would expect to find small fossils, perhaps, of maybe plant life down at the bottom of the fossil record. We call that a misplaced fossil. They're so common that we actually have a specific name for them if they occur below where they're quote unquote supposed to be, called a stratigraphic leak. Oh yes, it just leaked down through the layers, magically appears millions of years before it has supposed to have evolved. Okay, the most common misplaced fossil is the plants. Okay, particularly woody plants that appear in the Cambrian 100 million years before they were supposed to have evolved. Well, this is a problem for you if you want to believe in evolution, because here's the thing. Evolution teaches that everything evolved in the ocean first, right? Because having things evolve in the ocean and on land at the same time is just completely out of the question, right? What are the chances of that actually happening? So you have to evolve everything in the ocean first and then evolve it on land. There's another reason for this. The reason being that evolutionists believe that ozone is actually produced by the oxygen, which is actually produced by living things, okay? Which is true, right? They think all the ozone got there by oxygen, which is in our atmosphere. Now, why would oxygen be running around in the Earth's atmosphere? Why do we have oxygen? Oxygen's kind of a reactive little molecule. It's not stable, kind of like your mom. No, excuse me, sorry. No, having kids makes you unstable. I'm a good example of that. All right, so the thing is, oxygen is not a stable molecule. It's okay. It wasn't supposed to be funny. It's like everyone was thinking and I just said it. Anyway, so oxygen is not a stable molecule. If you know stable humans, I would like to study these for science, by the way. Oxygen is not a stable molecule. It gets absorbed by all the rocks and just basically gets pulled out of the atmosphere constantly. You're familiar with the fact that iron and steel will rust. But what are they doing? They're pulling oxygen out of the environment, okay, out of the atmosphere. So if you go to Venus, one of the things you'll notice, by the way, I don't recommend you go to Venus, but if you do, you'll notice that there's no oxygen in that atmosphere. The atmosphere is 90 times as thick as the Earth's atmosphere, and it's almost all CO2. The CO2 being kind of an inert, stable molecule, doesn't really get pulled out of the atmosphere very much. Oxygen, all the time. You go to Mars. What is the atmosphere on Mars? CO2. Almost no oxygen whatsoever in the atmosphere of Mars. No, not much of an atmosphere either. It's 10,000 times weaker than the Earth's atmosphere, to the point that a meteorite the size of a grain of sand will blow a hole right through your head. So if they're asking for volunteers for the Mars mission, you're not going to catch me going. They'll give me one of those dreadful starships. Anyway, so so where did the oxygen come from? It came from living things, according to everybody. But I believe it was the ozone layer. It came from the oxygen, and that it was designed into this planet, right? So it was all there from the beginning. Ozone layer, by the way, protects us from a lot of really harsh cosmic rays. Okay, the high energy rays from the sun would otherwise bombard this planet and kill basically anything that wasn't protected by water. And that's the key. So that's why evolutionists believe that things evolved in the water for millions of years before they crawled up onto the land and continued their evolution, because you have to have photosynthesis in the ocean, producing oxygen, building up oxygen in the atmosphere for any of the organisms that crawl up onto the land to survive. Okay, so this is a very big problem for evolution if you find land fossils down there in the Cambrian. You understand what we're saying here? Okay, so most of the time they ignore them, but I have a quote here from an evolutionist. Okay, despite tempting fragments of evidence, such as cutinized spores and bits of xylem dating back to the Cambrian period, most evolutionists believe that land plants did not evolve until millions of years later. And how long have the evolutionists known that we find fossils of land plants and spores in the Cambrian layer? Since 1974. This is a very common misplaced fossil. Okay. Spores, yeah, like from burns, right? Spore is basically a really small seed, right? They're cheap to make. You can make a bajillion of them. They don't last. They don't. They're not as successful as a seed, right? 1 in a million might form a new organism, whereas seeds are much better at surviving. So I will point out that once again, the evolutionist is arguing against the evidence rather than in favor. And there's a reason why. Probably none of you were aware of the fact that we find fossils of wood in the Cambrian layer. Because they don't want you to know. Because if you knew that land plants evolved at the same time, apparently, according to the evidence, as the ocean creatures, you would be like, wait a minute, how are you getting oxygen into the Earth's atmosphere before this? Oxygen is a reactive, unstable molecule, and it gets pulled out of the Earth's atmosphere like as soon as it gets formed. It's not going to be able to build up in our atmosphere. The only reason why there's oxygen in our atmosphere at all is because of all these plants we got burning out the oxygen, right? The oxygen you're breathing right now was farted out by a photosynthetic bacterium out in the middle of the ocean 20 years ago. Half of all the oxygen in the Earth's atmosphere comes from the ocean. That's one of the reasons why you go to the ocean, you sort of breathe it in, and you're like, oh yeah, that's stuff. Right? There's a lot of oxygen in that air. In fact, that used to be a prescription for a disease, right? You went to the doctor in London, you're like, I kind of feel so well, I got this cough, it won't go away. Doctor's like, a holiday to the sea. Yes, you're going to take your family for a couple of weeks and probably look about on the beaches for a while. You'll be right as rain. Well, it works because there's a lot of oxygen over there. Anyway, so the boundaries between these layers are smooth, even lines, no erosion, no bioturbation, no other disturbance to speak of. Okay. And again, we don't always find fossils in a particular order. Now, again, if you went to a government school, you would be taught that horses evolved, and they have evolved from the Eohippus. Okay, what is an Eohippus? Well, if you look at the skeleton of the Eohippus, it's a hyrax, right? We talked about this with the whole missing link between rhinos and horses. Hyraxes used to get bigger, okay? And so if you look at the fossils of them, they're about yay big, whereas today they're about Pikachu size, okay? So apparently, according to the evolutionists, the Eohippus evolved into the Oglohippus, which evolved into the Merychippus, which evolved into the Pyohippus, which eventually evolved into the modern horse. Unfortunately for the evolutionists, we actually find, I think it's Merychippus, in the same layer as the modern horse, and in one quarry, even actually higher. Okay, so a lot of places we actually find the three-toed horse in the same layer of strata as a modern one, and yeah, no evolutionist actually believes that this is how horses evolved. Merychippus. Maybe that's what the reindeer are, like Merychippus. You know, maybe that's how they can fly. So this is a great example of the evolutionists leaving something in the textbooks that we know is wrong, because what are they going to replace it with? They don't have another example. And of course, Cartwright is looking at those top three and saying, well, those are horses. Used to be more varieties of horses back before the flood, and now that we've destroyed half of the planet, we only have the modern horse. So that kind of sucks. We have to recognize that even one misplaced fossil by that margin is enough to call the whole timetable into question. Again, having a fossil of a plant that is apparently evolving at the same time as the ocean creatures is completely out of the question. So again, most evolutionists are completely unaware of the fact that we find xylem and spores in pollen way down in the Cambrian layer. We'll talk more about abiogenesis when we go over genetics. Okay. So maybe we have some time to get to part of the video on Glen Rose here. We can start it anyway.